All right, here we go. There is a functional relationship between the price of an iPod Touch little p and the weekly demand S. So we've got a function that says P of S, PS, baby. Okay, the price of an iPod depends on the weekly demand. Okay, so below is and it depends on how you want to write this. Hold on, we've got price. Let's see how we're going to set this up. We haven't decided yet. And then we've got weekly demand. Weekly demand is going to be S, and price is P. Now, it says their functional relationship between price of an iPod Touch P and weekly demand S. I don't know which one depends on which one. Let's read the problem and see. They do have a table. It says below is a table of the data that's been collected. They have the price in dollars, 150. If you were to set the iPod Touch at 150, 170, 190, 210, 230, 250. So, and then they say, based on the price, you're going to get a weekly demand. The lower the price, the more demand you're going to have, obviously. You know, if you found out today that right now there was a deal on iPhone, the new iPhone phone that's going to fold in half that's coming out later this year.
Dude, they're copying Samsung.
Okay, and they're going to have the first foldable iPhone phone, and it's going to be the flip phone. Okay, but they're doing something new apparently, so we'll see what it's going to be. It's apparently going to be better than Samsung, because remember, Samsung's JV and iPhone is varsity. But anyways, if they told you right now that they were going to drop the price, half price, what would everybody be doing?
I'd buy it.
There'd be more demand. So you can see that the demand goes up based on the price. The demand goes down if the price goes up. So it's actually going to be a negative correlation. A positive correlation has a positive slope. One goes up, the other goes up. One goes down, the other goes down. Rise of run, up. A positive rise, positive run would be a positive slope. Or if you had down and to the left, that's also a positive slope. Okay, so up and to the right or down and to the left. But if you have, look here, this is going up, this is going down. So that's kind of like going up and to the left or going down and to the right. So you're going to have a negative slope or a negative correlation. Positive slope is a positive correlation. Negative slope is a negative correlation. The closer you are to a correlation of 1 or negative 1, what does that mean? Does anybody watch the video? Strong correlation when you're close to 1 or negative 1. The closer you are to 0 means there's not much correlation. It's like Brody's test scores. Does the amount of gum he chew gonna increase his test score in college algebra? Maybe, but probably not a correlation there. There's probably not a correlation between how much gum Brody chooses and his test scores in college algebra. But you could probably say there's a strong correlation between the number of hours he studies and his college algebra score. That's going to be a strong positive correlation, or negative correlation if he doesn't study a lot. Okay? All right? So, actually, no, that's still positive correlation, because if the amount of hours you study goes down, your test score goes down. So both negatives and negative divided by negative, still a positive correlation. Can anybody tell me anything that would be negative correlated? Negative correlated, strong negative correlation. One goes up, the other goes down. One goes up, the other goes down. Does anybody know? Think of an example of one going up and the other going down in the real world. Strong negative correlation. The amount of exercise you perform, your weight will what? Okay? Your weight goes down. Typically. Not exactly, because it depends on what kind of training you're doing. If you're doing a lot of endurance. Okay. The amount of running and endurance training you do, what's going to happen typically to your weight? It goes down. That would be a negative correlation. And it's there's going to be a point where it levels off, obviously, because you can't go to nothing. But, and then the amount of exercise you do, typically your blood, there's a better example. The amount of exercise, what happens to your blood pressure? Goes down. If you decrease the amount of exercise, your blood pressure usually gets higher. So that'd be an example of it's probably not strongly correlated, but there's definitely a correlation, and doctors will tell you that. There's a correlation between exercise and blood pressure. It's not all that, because some of it's genetic, but there is some correlation. All right, so it says, find the linear model that best fits this data using regression. Regression is saying if you have a bunch of points plotted and you have like what's called a scatter plot, Regression saying is a model that is used to best fit the data, even though the data don't fall in a perfect straight line. So regression is an equation that can be used to best estimate based on the data that's given, or best approximate. Okay, it models, it forecasts. It's kind of like forecasting models with the weather. They're not going to be perfect, but they get you close. So it's a model, okay? In a perfect world, all the lines would fall in a straight point, but we know that's not always going to be true. There's going to be people that do not fit the model perfectly. Okay, so that's what regression is. Regression is just a model. It's a prediction equation based on the data that's given. All right, I'm going to tell you how to do this with your calculator, so you need to listen up. Fit the model that best fits the data using regression and enter the model below. For each entry, round the linear parameter to the nearest 0.01. So we're going to round to 0.01, which means how many decimal places? Come on, 0.01. How many decimal places? 2 decimal places. We're going to round to the nearest hundredth. 2 decimals, okay? And the constant parameter, so this is the slope. We're doing the slope to the nearest 2 decimals. What does it say about the constant parameter? So linear parameter is the slope. Linear parameter is talking about the slope. Okay, the slope is the linear parameter. What is the constant parameter? Can anybody tell me what the constant parameter refers to? The y-intercept. We want to round the y-intercept to the nearest 0.1 decimal places. So how many decimal places there? 1 decimal. Okay, 2 decimals for linear parameter, 1 decimal for constant parameter. The constant's the y-intercept. The linear parameter is the slope. Is everybody okay with y equals mx plus b? That was from section 2.1. Y equals mx plus b. Linear parameter, slope, constant parameter, y-intercept. Okay, y-intercept. Okay, y-intercept. There we go. Kind of did a little review there. All right. So it says fit this model. Now, you got to decide how you want to do this. They did not specify. Oh, yeah, they do specify. All right. Right here, they've got S equals T of P. So S equals total based on what? Price. So S equals. So they have the equation set up as S equals T of P. It's not toilet paper. I'm going to tell you how you do this. Because people are like, okay, how can I look at that? And I need you to pay close attention because this will be the rest of the year in every unit. And Brody does not want to struggle with this. So I'm going to make this really simple. Remember I said your X is your independent variable. The X is the independent variable. It's the input. We did that in chapter 1, independent variable. Okay, the Y is the dependent variable. It's the one that depends on the other. Now, most of you are going to make sense of this and say, the weekly demand, doesn't the weekly demand depend upon what price you set? How many are going to sell? How many people are going to show up and demand that iPod Touch, which nobody has anymore because we just use our iPhone. But when the iPod Touch came out, if they drop the price, it's not going to change the demand. Yeah, so the demand is going to depend upon the price you set. Okay, if I set the car price really high, you know what's going to happen right now? Ford, right now. Does anybody know what Ford is doing right now? And this is actually in response to Trump's tariffs. Okay, if you follow politics at all. Ford said, we appreciate Trump's tariffs because it's going to bring people back to buying cars in America. So for the next 5 to 6 months, we're going to let everybody in America buy a Ford at what our workers are allowed to buy it at. You can go to Ford for the next 5 months and buy a car at the employee discount. So right now, Ford, for the next 5 to 6 months, they're going to let you use the employee discount, even if you're not employed. So right now would be the time to buy a Ford because you'll save about $4,000 to $8,000 on a Ford because you get the employee discount. Because Ford is American made. And does anybody know what the tariffs are doing?
It's foreign.
They're going up because they're trying to say, okay, if Toyota wants to sell their cars here, they're going to get charged a tax because they tax us on things. They actually tariff us at like 300%. Did anybody know that? You guys pay attention on how the countries tariff America like crazy? Okay, it's like way 300%. So what Trump's trying to do, and I don't care what side of politics you're on, what he's trying to do, whether it works or not, we'll see. Even though yesterday 10 countries said, we'll drop our tariffs. Yesterday, did y'all see that? Taiwan said we'd drop our tariffs. India said we'd drop our tariffs. They said, we'll go to zero.
Yeah, drop
If you
the
take yours off,
tariffs.
we'll go to zero. So we'll see if it works. It's basically a bluffing game. It's basically seeing who's going to fold. It's kind of like playing chicken. But anyways, Ford right now. You could go right now. So what's going to happen to the demand of Fords because they're going to do an employee discount? It's going to go up. People are going to buy Fords like crazy. You just watch. I've never bought a Ford in my life, and I'm already considering it. Because me and my wife are talking about cars. Like, let's get a Ford. It's going to be $8,000 cheaper. Okay? So, and here's how you know this. Brody doesn't have to go to the equation and figure this out. He can just look at what's given here. Your equation's always y equals f of x. Remember, your input is x. Your input is in the slot. It's in the parentheses. So what is your x in this problem? P. The price. Okay? It's in the parentheses. It's the input. In the parentheses of your functional notation is always the input, the x. What it equals is the what? The output, or the y. So what's the output here? S. The weekly demand. And that makes sense because the weekly demand is going to depend upon the price you set. The price goes up, the demand's going to go down. The price goes down, the demand goes up. So this is probably going to be really interesting here as you think about this because this is a negative correlation. You're going to get a negative slope. All right, so here's how we do this. So what you need to do, take your calculator. I'm not going to do this. I'm going to try and do this with you, okay? So if you need to write down steps, fine, because I'm not going to write down steps. I don't have steps for you. You're in college algebra. Write down your own steps. Here we go. Go to the calculator. You need a calculator to do this. You need a graphing calculator to do this. All right. Don't me. Here we go. Okay? I'm way more tired than you.
No, Morris, I can guarantee I'm tired. You know.
Did you drive to Des Moines, Iowa after the NDSU track meet?
Morris.
Did you drive 8 hours?
4:30 a.m. with my boys on the weekend.
What time do you think I got to the hotel in Iowa?
I don't know, probably 2 a.m.
1 in the morning.
3 o'clock. Guess what time I had to get up?
4.
6. Because our first game was at 8 and we had to drive 25 minutes away. So I promise you I'm more tired. I'm going on fumes right now. All right, here we go. Turn your calculator on. First step, press stat.
Enter.
All right. Some of you have watched the video. If you haven't, that's on you. Press stat. I'm going to go quick, so you better keep up. You're going to go to edit, which is just option 1 or enter, whatever you want to do. Now, you get what's called the list editor. The list editor is where you plug in your table. Your calculator can't scan it. Because if you don't plug in the points, the calculator's not going to know what the points are. So we're going to put L1 is where I always put the X. I always put X in L1. So I'm going to go 150, I'm going to go 170, I'm going to go 190. I'm going to go, you can do your data if you want, 210, 230, and then 250, and make sure you hit enter after the last one. And you should get to a blank one, which is the 7th entry, and you should have nothing in the 7th entry. Now, I would scroll back up to the top and check them as you go, because the biggest mistake people make here is just entering data wrong. I'm going to go backwards, 250, 230, 210, 190, 170, 150, good. Let's go to L2 now. Now, you got to match the corresponding L2 values, the Y values, with their corresponding X. So 209 has to go with 150. So I'm going to go 209, enter, 204, enter. If there's already something there, I'll tell you how to clear it out. 191, hit enter, 183, hit enter, 176, enter, 176. Now, here's the number one thing not to do. If you already have something in your list, do not go up and hit delete on the L2 because I'm going to have to reset your calculator because you will lose the L2 and that will be a problem. Okay, the whole thing will be gone. Don't delete it. If you want to clear a list, you highlight the list and you press clear enter. The phone you only have to hit clear, but on the calculator you have to hit clear enter and it will clear the list. So if you want to do that, you can. If you want to practice clearing the list out real quick, go up to L2, hit clear enter, it'll clear the list out, and then you can retype it real quick. It doesn't take long. I mean, you guys text faster than, maybe not Keithan, because he doesn't know how to text.
I'm more of just a voice texter.
You are a voice texter, I know. I've read some of the stuff you've sent me. It's ridiculous. Okay, so I've got it typed in. Your data is now entered in the calculator. You're ready to go. This is pretty easy. Okay, now I don't know how this is set up. We're going to trust that it's set up already for a correlation coefficient, but if it's not, I can change that in a minute. All right, is everybody Stat, edit, enter the data. You good with that? Next step, you're going to press stat again. Now you're going to go to calculate. We're going to go to calculate. There you go, calculate. Yep, stands for calculator. And you're going to 2 regressions in this chapter they want you to do, a linear or quadratic. Now, here's how you know it's linear, because it looks like you were supposed to kind of plot the points, but I know it's linear because in the directions it says what? Linear. Now, if it's not linear, you're actually going to have to plot the scatter plot and see that the dots form a straight line. I'll show you how to do that in a minute. That'll be the last thing I show you, because some of these they don't tell you. You got to figure it out. Okay, I think most of them they tell you it's either linear or quadratic. If it's linear, under calc, we're going to use option 4. If it's quadratic, we're going to use option 5. Does everybody see that? We're using option 4 or 5. Linear is going to be y equals mx plus b. Quadratic is going to be y equals ax squared plus bx plus c. Okay, your general form, ax squared plus bx plus c. We're doing linear, so we're going to go to option 4, hit enter. Should take you to the home screen. Does it take you to the home screen? I can't keep up with slow drivers. Okay, is everybody at the home screen? Do you have this on the home screen? Okay. Yours will look a little different than mine, but it's very basically the same thing. Is that what everybody has? So linear regression. We got L1, L2. Now, you ready for your answer to your questions? I'm going to teach you how to do it. Okay. You ready to answer those later questions? This is going to help. This is the missing piece. Okay. Frequency list. Don't worry about it. Do you even have frequency list?
No. Yes.
You do?
Yeah. I do.
Yeah.
Just don't worry about it. Don't put anything there. Store regression, I do want you to put something there. You ready? I want you to tell the calculator to put the equation to y equals for you.
Y equals 40?
No. Whatever the equation for the line is, whatever the y equals mx plus b is. Okay, now they don't do mx plus b. What do? So what is the slope? It's not m, it's what? A is your slope, your b is your y-intercept. So they don't use m for slope on the calculator, they use a. So a is the slope, ax plus b. You tracking?
Yeah.
B is the y-intercept though. Now, I want to tell the calculator, after you figure out what the a and the b is, I want it to write the equation, y equals ax plus b, and I want it to put it in y equals for you. So here's how you do it. You press vars, V-A-R-S, variables. Now you're going to go to y variables, y vars. So you're going to have to hit the arrow to the right, go to y vars. And then you're going to go to functions, because we only do functions in algebra. And then you're going to put it in y1 in your y equals. So you're going to choose y1. That's going to store the equation into y1 for you. Now, I want you to clear out y1 right now. Clear out what you just put right there and see if you can get y1 up yourself. See if you can remember where it go. Light. Vars, y vars function y1. Watch me. This is how fast I can do it. I've had kids do it in less than 1 second. We actually timed kids 1 year, and we did it. So vars, y vars function y1. Look, I did it in about less than 1 second. Doesn't take long to type that in. Now press enter. There you go. Now hopefully it gives you the A. Hopefully it gives you the B. Hopefully it gives you the R squared. And hopefully it gives you the R. All right. Did it not give you R? All right, let's fix that. So what you do to fix that is you got to turn your diagnostics on. So the way you do that is you go to, let me see where it's at. You'll turn, once you turn it on, it's on. Let's see, where is it at? Is it under mode? Where is that dumb crap? And mine's always on, so I never remember where it's at.
Why is there so many options on the calculator?
Why is there so many options on your phone? Be quiet. Okay. Where is it at?
It's just a calculator. It's not that deep.
Keaton, this is the real world.
This is the real world. Thank you for stating the obvious. Where is the dumb diagnostics at?
You want me to Google it?
Why don't you just Google it on your calculator?
It's under mode.
It's under mode?
It's stat diagnostics. Is that what you're looking
Yeah.
Yes, there it is. Scroll down until you see stat diagnostics. I just never use this. Mine's always on, so never have to worry. Stat diagnostics, turn them on. Stat diagnostics, make sure they're turned on. Did everybody turn on their stat diagnostics?
Yes.
Now, I want everybody to go to the home screen and hit clear. Hit clear. Clear it all out. I want your home screen completely cleared.
It's gone.
I want you to tell me how you get that linear regression equation back up. How do you get that linear regression equation back up? Stat. No, we already got edit. We already did edit. The numbers are already in the table. So how do I get the stat equation up, though? Stat, calculate. What option? 4. Then we're going to go to store regression. How do we do the store regression? Vars, y-vars, function y1. Hit enter. Now you should get your A, your B, your R squared, and your R. Now your R squared is your squared correlation coefficient. We want that to be really close to 1, because the closer it is to 1, the better. Okay, now we're going to type in the equation. They wanted us to round to the nearest 0.01 for the slope, so we're going to round to 2 decimals. So here we go. Y equals mx plus b. Watch me. I'm going to type it in. Mine's negative 0.367. I'm going to round to, watch this, negative 0.37. Does everybody see how I rounded that? Okay, so negative 0.37x. Or no, we're not doing an x. We're doing a p. P is my x. You now know what your x is. And I rounded it from 3.6 to 3.7 because it rounds up. And then my b value is positive, so I'm going to go plus 263.26. That is my equation. Now, go on your calculator, press y equals. Press y equals. Do you see in y equals it typed in the whole equation for you with all the decimals? It didn't even round it. It typed it in the whole equation with all the decimals, which is the most accurate. Okay, so it's already in y equals for you. So then I can use that to answer other questions in a minute. Now, go back to the home screen. What's the correlation squared coefficient? What's the squared correlation coefficient, R squared? Is it above 0.95 or less than 0.95? Look at mine. What is mine? R squared.
Below.
Below. You got to choose yours. Values less than 0.95 may mean the model is not appropriate for making predictions. Mine's 0.944. It's close enough. We'll call it good. Okay? Now answer the 2 questions using unrounded model parameters. Now do you see why I stored it into Y1? Because it wants you to use the unrounded answers. So not the rounded model that we typed in for part A, but it wants to use the unrounded model, which we have stored into y equals. Did we store the unrounded version into y equals?
No. Oh, yes.
The unrounded version is in y equals. So here we go. What does the model predict that the weekly demand would be if the price is 197? Are you ready? You ready to do this? I'm going to teach you the easiest way to do it. There's actually 2 ways. You want to know when the weekly demand, what the weekly demand is if the price is 197. Price, was that X or was that Y?
X.
It's X. So one way you can do it is you can just go to the table. And you can go until you get to 197. Now I'm way up there. I don't want to spend all my time hitting the up arrow until I get back to 197. Do you? Who wants to hit the down arrow until they get to 197? Would you like the quick way to get to 197? Press second window. Table start. Change it to what you want. What do I want the table start to be at? 197.
Window.
Change the table start to whatever you want it to be. And go back to the table. There it is. At 197, now press second graph. Go back to the table. Press second graph. And then I know that it's $190.90. Now hold on, it says to the nearest 100. Because remember, the weekly sales were in thousands. You got to go back up here. Weekly demand is in thousands. So when my calculator says 190, that's 190. I got to move the decimal over. So if it's in thousands, I got to move the decimal over 2 places. So that's 190.
109.
That's 19,093, right? If I move the decimal 2 places. Sorry, is it in thousands or hundreds? What was it in?
Hundreds.
No, but what was the table in? It was in thousands. So I got to move the decimal how many places, actually? I got to move the decimal 3 decimal places because it's in thousands. So I got to move it 3 decimal places. So I got to take this right here I gotta move that Brody 3 down. I got my advisor coming tomorrow. So,
What?
His advisors.
for college algebra.
His advisor's coming.
So we're getting ready for it.
Hey.
So 934, 935.
You heard of that?
No, never heard of that.
Aubrey has.
Mm-hmm.
We're not doing it, are we?
That would not be good.
Don't do it. Don't do
What
it in
is-
school.
What is the schedule of like
It's not-
this weekend? Like, do we have a half day on Thursday?
I
or
know,
something?
but there is, the parking lot is free or something.
Oh, that splash thing or whatever?
Yeah, don't.
Oh, I'm so ready for that.
Don't do it here. I'm just telling you.
Nearest hundred. So there it is.
So ready for that.
What?
Do we have a half day on Thursday?
This Thursday?
Next Thursday?
Yeah.
Wait, why is it just
Early
900?
Because it says in your directions, it says round to the nearest hundred.
Oh, it's so.
So it says round to the nearest hundred. So I'm gonna put 190,000,
Not here.
900. Because I gotta round to the, so look, I moved the decimal over 3 places because it's in thousands. So I gotta move the decimal over. So I got 190,935, but then my part C says round it to the nearest hundred. So I gotta round 900 to the nearest hundred, that'd be 900. So it's 190,900. You just have to follow directions.
It's easy as that, buddy.
It's easy as that. Now, look at part D. According to the model, at what should the price be set in order to have the weekly demand be at 196,400 iPod touches? So here's what we're going to do. I'm going to round to the nearest dollar. So here's what you do. Okay, the easiest way to do this is just to go until you see when it's closest. You can just scroll in your table. But the problem is I want to get it to 196,000. So I'm going to scroll until I get close to 196,000. So I've got 196,000 there, 400. That looks pretty close. I got 196,800 there. There's 196,400. So that one's probably the closest. So I'm going to round to the nearest dollar. So I need to set the price at $182.
Where's my calculator? Won't let me go up.
Yeah, mine's like.
Like it won't let me go up.
You got to go over you can't not move along the Y's. You can only move along the X's up and down. So that's a good question in the table. You can only move up and down along the X's. The Y's you can't because the Y's dependent upon the X. So I'm going to do 182, hit submit, and I believe I got 100%. Yes, I'm good. I'm that good. I got it. Does that make sense?
Wait, how do you
So light.
The last one,
do
so I want to go to 196,400 in my table, the closest. There's 196,800 because remember, I got to move the decimal 3 places. There's 196,400. That's pretty darn close. So I'm going to do 182. Does that help?
Yep.
Yepper.
The iPod Touch. I do remember the iPod Touch. That was the one that where the
I
screen.
used to have one.
I did have an iPod Touch.
Back in my prime.
And then iPhones came out and it took over. All right. Does that help?
Yep.
Okay. All right, people. I hate to do this to you, but I got to get a little introduction so we can start. And I know we only got 12 minutes. It took a lot longer than I thought it was going to take, but here we go. I got to get an introduction so that when we come in here tomorrow, we're kind of not starting from scratch, but we're starting for 3.1.
We still have 22 minutes.
We got 22 minutes, so we got a good start. All right, here we go. To determine this chapter, polynomial functions, graph of polynomials, okay, we're going to determine if a function is a polynomial. Now, we've already studied one type of polynomial, the quadratic. The quadratic, okay, and you're going to want to know this. What page are we on in the textbook, by the way?
Page 235.
Today's a good introduction. It's easy. We've already studied the quadratic. The quadratic is a polynomial. The quadratic is a polynomial. It's an example of a polynomial. Now, there's other polynomials. We're going to get into x to the third, x to the fourth, and x to the fifth. This chapter and the next chapter are the 2 hardest chapters of the dry. You get through those, it goes downhill from there. The last chapters are easy. Okay, if you can get through the next 2, these are the hard ones. Okay, ax squared plus bx plus c. That's an example of a polynomial, a quadratic, a parabola. Okay, we're going to identify what's called the degree, the leading term, the leading coefficient, and the constant of the polynomial. It's very similar to the same thing we did with the quadratic. We're going to find end behavior of polynomials. both of even and odd degree, and we're going to see what happens. I'm going to bring a coat hanger tomorrow and bend a coat hanger for you. We're going to apply the intermediate value theorem, which is actually some calculus. You actually do this in calculus again.
Oh, let's go.
Okay? You're going to construct a sign analysis for a polynomial. We already did a sign analysis last chapter. That was the last thing we did. Okay, so we're going to use that sign analysis again. We're going to identify multiplicity. This is going to be really important because it's going to help us with the sign analysis. And then we're going to sketch graphs of polynomial using end behavior. So this is all. Section 1 is tough. It's a lot. We'll get through it tomorrow. So there are 3 families of functions we've studied thus far. Constant, which is f of x equals a constant. Can anybody remember what kind of graph a constant function is? When you just have f of x equals a number.
Straight line or a horizontal line?
It's a horizontal line. It's actually a horizontal line. Okay, it's a horizontal line. I'll give you an example. An example would be if we just had f of x equals 2. That would be a horizontal line at 2. Is everybody with me? I will be opening up the My Open Math today. Okay, what page are we on? I think we're right away. We're right in the beginning.
Yeah.
Okay, page what?
Page 235.
235. Is everybody with me? Okay, linear function. We've studied that in chapter 2, 2.1. That's y equals mx plus b. The calculator uses ax plus b. I'm going to continue to use mx plus b. And that's just a line, linear function. That's linear. An example would be like f of x equals 2x minus 3. Have a slope of 2 and a y-intercept of negative 3. Quadratic. These are all polynomials. All of these are polynomials. So we have a constant, linear, quadratic. Quadratic was our parabolas. And that general form was ax squared plus bx plus c, what we just tested on. Quadratic. So it has an exponent of 2, degree 2. We're going to talk about the degree today. Example would be if we had f of x equals, 3x squared minus 2x plus 1. All 3 of these, y'all should have told me to get rid of my other screen so you could see better. Is that better now? At the eye doctor. Better now? Better now? Better now? All right. All 3 of these belong to a much larger group of functions called polynomials. So polynomials, constant, linear, quadratic, is just a subset of a bigger set of functions called polynomial functions. All right, what is a polynomial? Here we go. Definition of a polynomial. It looks wild. It looks like something crazy you'd see like in a foreign language. Okay, you're like, oh my gosh, this is not even numbers anymore. It's just a bunch of letters. Let's explain it. A polynomial function is of the form. All right, look at it. F of x is equal to a sub n. This is a subscript. Okay, subscript, subterranean, below ground. Subscript is lower than all the other numbers. Okay, so a subscript is just a lower number. And all it is indicating the term that we're on. Okay, so it might be the 4th term or the 3rd term or the 1st term or the 0th term or the 2nd term or whatever. So a sub n is just what term you're at. X to the n power. The n power is going to be really important because the highest power in the problem leads the dance. If Brody goes to the prom, and apparently he is, okay?
Oh, Brady, you are?
Are you going to prom? You're not? I didn't go to mine either. Okay, actually I did. I felt sorry for somebody at the last minute. I took him to the prom. I did a sympathy date. I did it in underclassmen. They couldn't go to prom. Sophomores weren't allowed to go, and I was dating a sophomore at the time when I was a senior. And so I just said, you know what? Yeah, I know. Anyways. A sub n. X to the n power. This leads the dance. So if you go to the prom, if Carter goes to the prom, are you going to the prom? Okay, Keith, are you going to the prom?
I'm going to the prom.
Okay. If they dance, which apparently y'all don't do at the prom, somebody's got to lead the dance. Okay? Exactly. I'm telling you, in a polynomial, the one with the highest power always leads the dance. Okay, it leads. All right? So X to the n power.
Right here.
Highest power. Okay? I don't know. Who are you going with?
Katie Bride.
Never mind, she's going to lead. All right, here we go. So we got x to the n power. Then it goes like this. Now watch. It counts down because we're going in what's called descending order. So if we start with the 6th power, if we started with the 6th power, this would be a sub 6 times x to the 6 plus n minus 1, it counts down. So the next one down would be a sub 5 x to the 5th power. The next one would be a sub 4 times x to the 4th power. Then the next one would be a sub 3 times x to the 3rd power until you get to a sub 2 x squared plus a sub 1 x to the 1st plus a sub 0. Now, some people are like, what happened to the x? Well, let's see. A sub 2 x squared plus a sub 1 x to the 1st power. What happens to the x? A sub 0 x to 0 power. What's anything to the 0 power?
0.
Nope. 1. Anything to the 0 power is 1.
Ooh, yeah, put it there.
Memorize. You need that for chapter 7. Anything to the 0 power is what? That would have been a while ago. You would have, last time you had that was either pre-calc or if you had pre-calc or algebra 3, you should have learned it. Algebra 3 or pre-calc, you should have learned that. Anything to the 0 power is 1. The other time you would have had it is in 9th grade. All right, so anything to 0 power is 1. So that just goes away. So does everybody see why you just end up with a sub 0? You with me, Addie? Okay. All right, so everybody see why you end up with a sub 0. Where a sub 0, a sub 1, and a sub n are real numbers, and n is going to be greater than 1. The exponent, whatever the exponent of the polynomial is, it has to be greater than or equal to 1. We're not going to deal with negative exponents. Everybody say it. We're not going to deal with what kind of exponents? We will do that next chapter. And that turns it from a polynomial to a rational. Okay, where you have a denominator, because negative exponent, you send them to the basement. So right now, n is greater than or equal to 1. All exponents are positive, and they're natural numbers. So are we going to have any exponents that are decimals? No, natural numbers are your counting numbers. So the only exponents you're allowed to have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on to infinity. You can have any exponent as long as it's positive and it's a natural number, a natural counting number, no decimals. So the domain, you're going to love this. The domain of every polynomial function is what? Get that memorized. That's a free point on all your problems you're going to have to graph.
All real numbers.
All real numbers, double bar R.
Morris, could you ever have
Easy
a,
point.
Easy point.
could you ever have a exponent with a decimal or no?
Can, but it's not a polynomial anymore.
Are we gonna have to do that?
No.
Okay.
Okay? Well, yeah, in chapter 7.
Chapters.
Okay? We'll do like 1/2 powers and 1/3 powers, and then they end up being root functions. They're not hard. It's like I said, those chapters are actually easier. All right, here we go. Consider the polynomial. Here we go. We got our first look at a polynomial. Consider 4x to the 5th minus 3x squared plus 2x minus 5. Now, just because it's a polynomial doesn't mean you have to have every term. We get to synthetic division in this chapter, because we're going to do a lot of synthetic division in this chapter. You're not going to have every term. You start with the 5th power. So there's Keithan. He's leading the dance. He's to the 5th power. Okay, because Keithan apparently leads the dance. All right, so 4x to the 5th power. All right, we can rewrite the formula as 4x to the 5th plus 0x to the 4th plus 0x cubed plus negative 3x squared plus 2x plus a negative 5. Now, it's not required to do that, but that's really what that means according to this definition. That's the full thing expanded according to this definition. That's all the terms. So what does the 0 terms represent?
Nothing.
It represents there's no x to the 4th term and no x to the 3rd term. That's exactly right, Brody. It represents there's nothing there. That's why you don't see anything in the original equation. The zeros are telling you there's no x to the 4th term, there's no x to the 3rd term. Is that okay? Okay, let me know if you got questions. Now, comparing this to the definition of the polynomial, we can identify that the highest power is 5. Everybody agree? The highest power is 5. That leads the dance. Your a sub 5 is the coefficient of the term that has the power of 5. So a sub 5 is just the coefficient of the term with the 5th power. A sub 4 is the coefficient of the term with the 4th power. A sub 3 is the coefficient of the term with the 3rd power. A sub 2 is the coefficient of the term with the 2nd power. A sub 1 is the coefficient of the term with the 1st power. And a sub 0 is the coefficient of the term with the 0 power, which ends up being the constant. This is the constant. Can anybody remind me? I know Aubrey's going to be able to tell me, why is the constant important?
That's your y.
That's your y-intercept. The constant is going to be your y-intercept. So everybody write that down. This is the y-intercept. And you know why it's the y-intercept? Because the y-intercept is when x equals 0. If x equals 0, what's going to happen to all the terms when you plug 0 in? They're all going to zero out. If you plug 0 in, my peeps, look at what happens. If you plug 0 in here, wouldn't this zero out? Would that zero out? Would that zero out? Aren't you just left with the constant? So if you want to go back to page 235, I think it was on, and write a sub 0 is the constant. That is the constant. That's the y-intercept. Have that in your notes. That's huge.
What are we gonna do with that?
Oh, we're going to graph. All right, here we go. We're going to determine if the following are polynomials or not. Explain your reasoning. And now here's the number one thing you can't have. You cannot have a fraction. Polynomials do not have fractions where the variable... You can have a fraction coefficient. I didn't say anything about that. Like we can have 4x to the fifth minus 1/2 x squared plus 2x minus 5. That's fine. You can have coefficients that are fractions, but we said that n, go back up here, we said that n, the exponent, n is the exponent. Everybody say n is the what? Exponent. That's the degree. We said the degree has to be a natural what? It can't be a fraction. It can't be negative either, because a negative is going to put it in the basement, which is a fraction. So when I ask you, are these polynomials or not, if you see x in the denominator, automatic no. So A is a what? No. B's a what? No. C's a what? No. D's a what?
Maybe.
That's x to the 1/3 power. Is that a yes or a no?
No.
No. What about E?
No.
No, it's a bird. No, it's not a bird. We call it the flying V. This is the flying V. Flying V. No. So we got no, 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 no. What about F? What about F?
It's no.
Yes.
You gotta be joking.
It's the only one that's yes. That's a constant. That's a horizontal line.
I was just following the trend, dude.
Okay. Yep, and I trended you to a yes.
Why is D though? I thought it was only in the denominator.
All right. You can't have x in the denominator and your exponent, the cube root, okay? The cube root, x to the 1/3 power. That's, and I don't know if you remember that, doing exponents with fractions from pre-calc, but it's x to the 1/3 power. Your exponent has to be a natural number. So anytime you have a root, just go ahead. Roots are not polynomials. Square roots, cube roots, fourth roots, they're not polynomials. So we got no.
Oh, the Morris says another one.
What?
It's right. It's sitting at the bottom.
F is yes.
I keep going down. Right there.
G is a no. No, this is just the solutions.
No.
This is just telling you why. So that's a no. That one's a no.
It's all a no.
They're all no's.
No.
And I don't care about the simplifying. It can be, like, some of these you can simplify, so the textbook's going to tell you. Some of these you can actually divide. So this one's definitely a no. They could tell you B. You could simplify it. So even though it's a no according to my definition, and that's the definition we're going to go by, you can factor an x out on top.
Test, we should just have a bunch of these.
Shh, quiet. All right, 4 plus x squared over x. I can cancel the x's out, and then it ends up being a polynomial. But I go by the original equation, because in calculus, that's what you do. You can't have a variable denominator. You can get it to simplify to a polynomial, but the polynomial ends up having a hole in it. Because when you get something to cancel, that gives you a hole.
Wait, so technically that one's a yes?
But no, but it's a no.
But it's a no about what we're going on.
We're going no by the original.
As a whole.
You can simplify it to a polynomial, but it's a polynomial with a hole in it. Okay? Same thing. No, letter C is a definite no. That's a 100% no, no,
Wait,
no.
why would the absolute? Oh, 'cause it's
Absolute value is a flying V.
Okay.
Yep. So anytime you have roots or absolute values, they're going to be no's. Okay. Last thing I want to do here. Yep. So Z of x is 0. That's just a horizontal line at 0. We said horizontal lines were a part of the polynomials, did we not? Yep. Horizontal lines, and parabolas are. All right. Now, last thing today. I want to be able to pick up here tomorrow. 6 minutes. If f is a polynomial function, if we decide there's no x in the denominator, there's no absolute values, there's no square roots, there's no cube roots, and we decide Basically, you know what a polynomial is? It's just powers of x. All a polynomial is, if you want to write that, all a polynomial is adding or subtracting. Now, my college person tomorrow will be mad at me if I say that instead of saying sum or difference. Because sum means add. But I tried to relate to what you guys. Adding means sum, subtracting means difference. It's the sum or difference of powers.
Really just professional tomorrow?
No, I'll have fun. I'll have the same fun. I don't get nervous when these people come. They should be nervous with me. All right, here we go. Sum or difference of powers of x. So what you're going to get is you're going to get a bunch of powers of x that are added or subtracted. X to the 5th power, x to the 4th power, x squared, x, no x. Okay, you just get a bunch of powers of x that are either added or subtracted. Okay, so that's all a polynomial is. All right, let's review. Polynomial. So you've got this thing. It's going to be in descending order. So we're going to go from the highest power down to no power. We always go down to the constant. Everybody say it with me. We're going to go from the what? Highest power down to the what? Constant. Highest power down to the constant. The leading coefficient, a sub n. A sub n has a name now. We're going to call it the leading coefficient. The leading coefficient, okay, is going to be in the leading term. The leading term is the power couple. Okay, there's going to be one couple at the prom that's going to act like they got all they're all that in a bag of chips. Okay, it's going to be Keithan. He's going to come rolled up in his pinstriped tux and go, look at me. Okay, I'm just using Keithan's letting me pick
I
on.
was thinking more like not that more.
Okay, you're thinking not that. He's just going to be a penguin. All right, here we go. So, but if you're like that power couple, you're like, you dress like really flamboyant. You're going to have like the most loud dress and loud tux, and they're going to be the power couple. Okay, let's go with that. Just because it's prom's coming up. All right, the leading term is the one that has the highest power. It's the one that leads the dance. The a sub n is called the leading coefficient. So the leading term is the one with the highest power. The number in front of the leading term, a sub n, is the leading coefficient. I want to get through these before tomorrow, okay, because it'll help. And I'll review them again tomorrow. A sub 0 is the constant. We already did that, okay? And if we have f of x equals a sub 0, okay, we say that it has degree 0 because there's no x. There's no x. And then it's what kind of a line? It's a horizontal line. So this is a horizontal line. Horizontal line. F of x equals 0, we say has no degree. I don't know. I call it degree 0 still. I just call them all degree 0. I wouldn't get too worked up on that. There's not going to be a test question that says f of 0 equals 0 has no degree. They're all just degree 0, okay? All right, and the degree of the polynomial is whatever n is. All right, I got 2 minutes. I'm just going to do one quick example, and then we'll stop. We'll pick up here tomorrow. All right, so just let me show you, just to make sure you know. So coming in tomorrow, we'll have a pretty good idea. Look at letter A. Is this a polynomial, first of all? Are we just adding and subtracting powers of x? Yes. What's the highest exponent? 5. So letter A, the degree is 5. And you're gonna have actual open math questions where this is all you do. You're gonna love this. And I have test questions where this is all you do. So the degree is 5. All right. What's the leading term?
4.
Okay, the leading term is the whole a sub n x to the n term, the whole thing. That's the leading term. So the leading term is that. So that'd be 4x to the 5th. What's the leading coefficient, a sub n? Just the positive 4. And then what's the constant, a sub 0? -5. I'm going to use that tomorrow. So degree, instead of writing degree, we're going to write n. Can we do n for degree? So n is going to be degree. Leading term is going to be a sub n, x to the n. Leading coefficient is just going to be a sub n, and constant term is going to be a sub 0. Is everybody okay with that?
Yep.
All right, that's where we'll pick up tomorrow. I will open the My Open Math by this afternoon.